What is up, guys? This is the second video in the Digital Logic playlist. So for this video, I'm going to introduce the binary number system. So a binary number is a number expressed in the binary numeral system. Sometimes you'll see it called base 2. The binary system uses two symbols to represent numbers. Most commonly, these symbols are just going to be 0 and 1. The benefit of using binary in computers is that it's straightforward to implement. When designing logic circuits, each electronic signal takes the value of either a 0 or a 1, which the signal itself will be low or high. The information in modern computers are some combination of zeros and ones. So a binary number would look something like this. You have some random number, and let me keep it 4. So this right here is a number in the binary system, and it stands for something, and we need a way to convert this to decimal. So that's kind of the long-term goal, is to be able to convert between decimal and binary and to just become more comfortable while working in the base 2 system. So I think in order to better understand the binary system, it's helpful to look at the familiar decimal or base 10 system. In the decimal system, we use 10 different symbols to represent integers, and these symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So, like most people learned in elementary school, you have something called positional notation, which is where you get the hundreds and tens and ones place. So if I show you a random number, let's do 253, we have the ones place, the tens place, and the hundreds place. Another way to look at this is the 10 to the 0th place, the 10 to the 1 place, and the 10 to the 2 place, which 10 to the 0 is 1, 10 to the 1 is 10, and 10 to the 2 is 100. So the encoding of the number 253 can be written as this: 2 times 10 to the 2 plus 5 times 10 to the 1 plus 3 times 10 to the 0, which is 200 plus 50 plus 3, which is 253. And another thing you probably heard in elementary school was, oh, you have 2 100s, 5 10s, and 3 1s. And that's the sort of simple way to look at that. It's really that straightforward. So how do we relate this sort of positional notation and looking at a number in decimal? How do we do that with binary? Well, it's pretty similar. So a binary number, let's look at this random one, about 1011. The position of the numbers are still significant. So instead of 10 to the 2, 10 to the 1, and 10 to the 0, we're in the base 2, so it is 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. And similarly to how we did 2 times 10 to the 2 plus and all that to get our number, it's going to be 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. 2 to the 3 is 8, so we have 8 plus 2 to the 2 is 4, but it's times 0, so it's 0, plus 2 to the 1 is 2 times 1 is 2. 1 times 0 is 1. So the binary number 1011 is the decimal number 11. So using combinations of the symbols 0 and 1 to represent integers seems a little bit awkward at first, but in the computing world it makes things way more simple. So when you have a number in binary, a single digit in binary is called a bit. When you have 4 bits, it's called a nibble, and when you have 8 bits, it's called a byte. So 1 bit is just a single binary digit. When you have 8 bits, we consider that to be a byte. The importance of this will become apparent later on. But for binary numbers, that's basically the dirty, quick intro to it. There's so much information on it available online, and I'm going to link tons of stuff in the description, so please do check the description. And right now it might seem a little bit awkward, but I'm going to do a lot of examples of converting between binary and decimal to binary, and there's a few different methods to doing this, and it'll just become a lot more apparent as you watch the next few videos. But please do check out the stuff in the description. I'll see you in the next video.